Hello everyone, in this video we will be discussing about Pandas. Pandas is a very famous and a popular Python library for data analysis and data manipulation. The name of the Pandas was derived from Panel Data System. It was developed by Wes McKinney in the year 2008 and the stable version of Pandas is 1.5.0. Now let us jump to the installation of Pandas. So here I'm using Jupyter Notebook. Jupyter Notebook is a very famous and popular IDE for Python. You can use some other IDEs like Google Colab or other, but I prefer Jupyter Notebook. So let us see the installation for Pandas. So the syntax is, what we'll do is pip install Pandas. So this is the syntax to install any library in Python. So what we'll do is pip install and the package name. So now here we want to install Pandas, that is why we are giving Pandas. So installation for Pandas. Okay, so to run the cell we use shift enter. So here it is showing me requirement already satisfied. So here actually I already have Pandas installed, that is why it is showing me requirement already satisfied. So once the installation is done, you can directly import the library using the syntax import the package name, that is Pandas. Now I want to give an alias name to the Pandas, because whenever I want to use Pandas I have to write the whole name Pandas, and I don't want to write the whole name Pandas, so I can give an alias name. So I'm using here referring the Pandas as PD. So this PD is the alias name, so we'll be calling the Pandas later in the code with PD. So now we have imported Pandas, so we can now use Pandas, its methods for our requirement. So now normally in Pandas you have a data frame. Data frame is a collection of rows and columns. So a data frame stores our data, and it stores the data in rows and columns. Okay, so we can create a data frame. So for example, if I want to create a data frame for the employee name and employee salary, so this is how we'll create. We'll call PD and the method is data frame, and we'll pass the values inside using dictionary. So here the first I want to have the column name as emp underscore name. This will be our column name, and I'll pass the values for emp underscore name in a list. So here we'll pass the names, for example some dummy names. Okay, and now another column I want to make, so I'll give the comma, and another column I want to make salary. Okay, and again I'll pass the values of salary in a list. These are the salaries. Now I will save this data frame in a variable called as, for example, emp underscore data. So this data frame we are storing in a variable emp underscore data. Now to see this data frame, what we'll do, we'll print emp underscore data. Now you can see here, we can see the data frame here. You can also use the method called as head to see the first 5 rows of a data frame. So here we can see this is the data frame. Our first column is emp name, the second column is salary. So we've created this data frame using the method data frame, and we've passed a dictionary. So the dictionary, we've passed the dictionary, the keys were our column names, and the values will be we have passed in a list. This is how we can create a data frame. Now for example, I want to see the data type of emp underscore data. So this returns the data type of the variable emp underscore data. So here you can see we are getting the type as data frame. Okay, so the type is data frame. Similarly, data frame actually it is a 2D data. So you have two columns actually. So more than one column data or a 2D data is called as data frame. But if you have 1D data, for example, you have a single column, then that is called as series. So single column or 1D data, 1D array is called as series. So if we want to create a series, this is how we can create a series using pd.series, and we can pass some values in using list. So I'll pass some values, for example, some fruit names, for example. So this is we are creating a series. So see, you can see we have got a single column. We can save it in a variable called as fruits. Now I can, if you want to see the series, this is how we can see the series fruits. Now if we see the type of variable fruits, now we'll get series. Okay, series. So series actually it is a 1D array. 1D meaning you have a single column. Data frame, when you have a multiple columns or more than one column, that is called as data frame. So it is a 2D array. A series is a 1D array. So to create a series, we use method series, and you can pass the values inside it through the list. Okay. Now, if we want to import a data, already I have a data in Excel file or a CSV file, and I just want to import it in Pandas for data analysis and data manipulation purposes. So we can use the method read underscore CSV. If we have a CSV file, so we can use read underscore CSV, and I'll pass the location of the file, the location where our file is stored. So for example, my file is stored in data, and I have a file this is tips dataset CSV file, and I'll also give the link for this file in the description so that you can download and practice it. Okay, so I'll just import this. So this is how, see, we've got complete data which was there in our CSV file. So to import the data from a file, so I'll save this in a variable called as data. So to import data from CSV file, so to import data from CSV file, we are using method read underscore CSV, and here we'll give the location of the file where the file is stored, okay, on our computer. Now if I want to see the first 5 rows of this data set which we have just now imported, so we can use data.head. So it returns the first 5 rows of the data set, data.head. I want to see the last 5 rows, we can use data.tail. Data.tail is used to see last 5 rows. Okay. Now I want to see the information of a data of this data set which we have just now imported. So the method is data.info. So here it is returning all the column names and whether they are non-null values and what is the count. So we have 244 values in each column, and what is the data type. So float 64, this 64 it actually refers to bits. Float 64 object. So here the strings are referred as objects. Okay, so the data type of each column and the count of each column is returned when we use .info. So .info is the method. It returns the information of the data. Okay, and also it returns how much memory it is using. Now if you want to have the information but not the physical information or the columns, about the columns or the data types, now we want the information on the statistical information. So to get the statistical information of a data set, we use data dot describe. Describe is the method to get the statistical information of a data. Here you can see I'm getting the mean for the columns, the standard deviation, the minimum value or the least value which is there, the 25 percentile, the 50 percentile and 75 percentile values, and the maximum, the highest value there in the column, and the count. 244 values are there in each column. So this describe method, it is returning the statistical information of the data set. It returns the statistical information of the data set. Now for example, I want to see the first row. Okay, I want to see just first row. So what I'll do is I'll use data dot loc, that is log, data dot log, and I'll pass value 1. Okay, or value 0 because the index starts from 0. So this is the first value of a data set. So the row total bill, the value of total bill is this, the value of tip is this. So the first row, so data.log is returning actually it is returning the row you want. We are using it through the index position. So at the index position 0, this is the row, these are the values available at index position 0. If I want to see a row at index position 100, for example, so these are the values. So this is how you can see a particular row based on its index position. If I want to see the rows from, for example, from 10 to 20, so here we can do the first, I want to see all the rows from 10 to 20. So here it returns all the rows between 10 to 20. So we can use loc, log. So log is used to slice and is used for slicing and indexing the data. Okay, so here what we are doing, we are slicing the data from the row 10 to 20 for slicing. And indexing is nothing but getting a row by its index position. So to access the element by its index position is called as indexing the data set. For example, I can also use data.log for example, I want to just see all the columns where the total bill is above or greater than 10. So this is how I can use data.log, and I'll give total underscore bill greater than 10. Just a second. Here's, now we can see it returns all the columns where the total bill is greater than 10. So this is how also we can do, we can apply the logics, we can apply the conditions to see the data. Okay, or for example, I want to see all the columns or all the rows where the sex is female. So here I'll just change the column name, I'll change it to the column sex and equals to, I want to see the females, so equal to female. So now it returns all the rows where the sex is female. So data.log is also used okay, where you can see the data with a condition. So using data.log. Okay, so data.log helps you for slicing, indexing, and based on conditions as well. Okay, you can also give some condition to that. Data.log. So it is used for slicing and indexing the data set. Similarly, for example, I have this categorical values here in time. Here I can only see some values, or here in day I can only see Sunday, Friday, and Saturday, Thursday. I don't know whether the Monday or Tuesday exist. So if I want to see all the unique values, all the unique categorical values which exist in a column, so this is how I can see it by data, the column name, that is day dot unique. Unique is the method to see all the unique categorical values present in a column. I'll just put, okay, so now I can see these are the different unique values available in the column. So Sunday, Saturday, Thursday, and Friday. So unique is actually is a method to see the unique values, unique categorical values present in a column. For example, I want to just select a single column. Okay, I want to have total bill, and I don't want any other column. So to select a single column, you can use like this: data square brackets, and I'll give the column name, that is total underscore bill. So now I'm getting the only that column, the single column, that is total underscore bill. Okay, and I can save with this in a new variable, that is total underscore bill. So now this total underscore bill variable is storing a column total underscore bill, and this is actually a series. If we see the type total underscore bill, now total underscore bill is a series. Why? Because it is only having a single column, whereas this data, it is a data frame because it is having multiple columns. So to select a single column, you can use like this. For example, I want to drop a column. I don't want the smoker column. Okay, so I want to drop a particular column from the data set. So you can use data.drop. Data.drop. For example, I want to drop the column smoker. Okay, so I'll give smoker inside square brackets, and I'll also specify the axis. Axis actually I want to specify because I'm dropping a column. So if you're dropping a column, that means you're dropping at the x-axis. You're dropping at the y-axis. Y is the column, so it is specified through 1. So axis is 1. So you can see here now the smoker column is dropped. You cannot see the smoker column here. So this is how we can drop a column. To drop a column, use drop method. So this is how we can drop a column. Now I want to add a column. For example, I want to add a new column, and that column should be, for example, a total column, where it should have the sum of total bill and tip. So I want to do the sum of total bill and tip, and I want to store it in a new column. So this is how we can do. So I'll create a new column, data, and this will be total. The name of the column will be total, and that column will store the sum of total bill and tip. So data total underscore bill plus tip. Now if we see data, you can see here now the new column with the name total has been added, and here we can see it is a sum of these two columns. So this is how you can do operation on two columns and add in create a new column as well. So here we are creating a new column and we are storing the values, the sum of total bill and tip column into this new column. Now, for example, I want to see whether our data set has some null values or not. To check null values in the data set. So to check the null values, we use data dot, there is a method called as is null. Okay, is null. So is null actually returns whether where the data set, whether the data set has null values or not. So you can see the false meaning there is no null value, but I don't want to see like this for each row. I just want to have a total number, sum. So what we'll do, we'll sum all the values dot sum. So it will return exact number for each column. So we can see 0 for all the columns, meaning no column has any null value. Okay, so if there would have been any null value, then it would show the number here. Okay, total bill, it will show like 2, so meaning we have two null values in total underscore bill. Now here it is showing 0, meaning you have no null values present in the data set. So this is how we can check the null values in the data set. So I hope everything is clear what we have discussed about all the methods of the pandas. These are very important methods of pandas which we use for data analysis and data manipulation. So I will give the link for this file and the data set in the description so you can download it and practice it. Thank you.